All right. So here's the plan for today. We're gonna do intro to next unit. So we don't have time to just like take a week off. I know we wish we did, but we don't. So this topic has a delta math, okay, but it goes in Q4. So what our order is gonna be today is we're gonna run through these notes. They should take about 40 minutes, maybe less if we go quick. Okay, and then after we finish this, your priority is to finish your College Board AP Classroom assignment. Okay, that it's been open since Wednesday when I wasn't here, but I want to make sure you at least have time in class to work on it if you didn't already do it. Okay, then when you finish that, you can work on old homework. The deadline for that is Tuesday. Okay, or if you're totally caught up, then you can do this homework, but remember, it's not due, it won't go on this quarter, it'll go on Q4. Q4 of your senior year. Wow. Okay. Is that kind of crazy? Okay. So let's look at your notes for today. A separable differential equation, okay, is going to be, so let's just first say what a differential equation is. It's just an equation that has a derivative in it. Okay, so differential equation sounds scary. Okay, but really it just means that you have a derivative equation. A separable differential equation is when you can write it where the x and y stuff are either multiplied together or divided together. Okay, so notice not added, not subtracted. They have to be multiplied or divided for it to be considered separable. Okay, the way that you solve a separable differential equation is as follows. Step number 1 is because it's separable, you're going to separate it. Okay, all of your y stuff will go to the left with the dy, and all of your x stuff will go to the right with your dx. After you separate, okay, y is on the left, x is on the right. Okay, then you're going to do the antiderivative on both sides. Okay, and an antiderivative and an integral are the same thing. So if I say integral, that's the same. Okay, that is going to give you your general solution. Now, from here, you're going to solve for y equals. And then you're going to find the value of your plus c, which would make it your particular solution. Okay, so those are your steps. So now that you have your steps written down, let's do some examples. So let's start with number 1. First thing I want to point out to you is that this is a differential equation because it's a derivative. dy dx means derivative. Okay, also it's separable because how is your x and y stuff related to each other? Are they multiplied or divided with each other? Divided. All the x stuff is divided by the y stuff. So put your dy dx right here equals negative sine x over 2y. And we're going to separate this to get only y stuff on the left, only x stuff on the right. So the way that we're going to do that is I see that my 2y is divided. This is a divide by 2y. So to undo that, I'm going to multiply by 2y. Okay, on both sides. And when I do that, what happens here if you have the times and the divide by on the 2y's? They cancel out. Very good. Okay, the other thing that I'm going to get rid of is the dx on the bottom. So I'm going to do a dx here and a dx here. And then on the left-hand side, now I have a dx on top and on bottom. What can happen with those? Cancel them out. So here's what's left. I have a 2y dy and a minus sine x dx. So step number 1 was to separate. All my y stuff is on the left, x stuff on the right. What's the second step on your rules? Antiderivative on both sides. Okay, so if I want the antiderivative of 2y, remember you're going to up the power, then divide. So y would go to what? Then I would divide the squared on the 2 in the front, which would give me a what? 1. You can put it or not. It's up to you. Yeah, I guess I'll put it. Okay, then negative sine x. What's the antiderivative of that? Think snow cone over here. So if I'm on negative sine, antiderivatives, I go up. I'd be at positive cosine x. Okay, plus c. Now, usually when we do an antiderivative, we would put a plus c on both sides. Okay, but think about it. If this c is, let's say, 5, and this one is 10, I could just minus the 5 over and just have 1c. So you're not going to plus c on both sides, just plus c on one side. Usually you would pick the x. Okay, so from here, we separated. We took the antiderivative. Now we're going to solve it for y equals. So if it's y squared equal to cosine x plus c, how can I get my y alone without the squared? Take the square root. So your general solution is going to be y equals plus or minus the square root of cosine x plus c. Okay, that is your general solution. Okay, and the reason that it's called a general solution is because we don't know what c is. Okay, there could be a particular number there, but for right now, we're just putting the plus c as a placeholder. Okay, you're going to use this information right here to find what the c is supposed to be. So if you look at this right here, it says that f of 0 is -2. Okay, we're going to use that to find our plus c. Okay, so remember, this is the x value, so I'm going to plug in 0 where the x is, -2 where the y is. So I'm going to have this now. -2 equals plus or minus the square root of cosine x is a 0 plus c. What is the cosine of 0 though? What number? 1 plus c, good. Okay, now from here, I'm about to square both sides because I want to get rid of this square root. Okay, but before you get rid of it, you have to pick if a plus or a minus matches the y value that you were given. So since I was given a -2, I'm going to choose the minus. Sorry, not the plus, just the minus. Okay, and then my next step, I'll square both sides. It'll go away. Okay, but you do have to pick before you do that. So I'm going to square both sides. What is -2 squared? 4. And then on the other side, when I square, the negative and the square root cross out, just leaving me with a 1 plus c. And then what would my last step be there to get c by itself? Minus the 1 across, which means your c is what? 3. Okay, now from there, let's write our particular solution. So it's going to be y equals, we picked the negative square root of cosine x, and then my c is a plus 3. Okay, and that would be your particular solution. Okay. Make sense a little bit? All right, let's take a look at number 2. I have x and y stuff, okay, but they're split by what sign? What operation is the x and y stuff split by? Division. And remember, multiplication and division count as separable. Okay, also it's a differential equation, so I have a dy dx. So first step is going to be to separate. So if it's a 12x over a y squared, my y squared is currently divided. So to get it to the other side, how am I going to get rid of it? If it's a divide by and I want to undo it, I have to multiply. And when I multiply it on the right side, now my y squared is gone. My dx is also divided. To undo it, I'm going to multiply it. So my dx will go here and here. But then on the left-hand side, the dx will cross out the old dx. So now we have y squared dy equals 12x dx. Questions on that so far? All right, so we split everything up. Now we're going to do integral. Okay, what is the antiderivative of y squared on the left-hand side? What would that be? Good, so the y would go up to a cubed, and then you divide the cube, so it'd be a 1/3. Okay, now let's do the 12x side. So my x, I have to bump it up 1 power, so x will go to an x squared. And then I'll divide the 2 on the 12, that'll make it a what? 6 plus c. Okay, remember we want to get our y by itself. So if I have a 1/3, how can I get rid of that? Multiply by 3. Now, when you times by 3, you really need to times by 3 everywhere. So I'm going to put a times 3 on this side, that will cross out. And then I'm going to put a times 3 on this side too. Which means that now I have y cubed equals 3 times the 6 makes that an 18x squared. And now this is a little bit weird, but I just want you to just trust me on this. Okay, do we know what c is? Then if we times it by 3, we're not going to call it 3c. We're just going to keep it plus c. Because think about it, we already didn't know what it was to begin with. So we still don't know what it is. So we're just going to keep calling it c until the very end. Okay, when we actually find it. Okay, last step. We have a y cubed. We need y by itself. How do we undo the cubed? Cubic root both sides. So my final answer will be y equals the cubic root of 18x squared plus c. Do you need a plus or minus option for a cubic root? No, only square roots, or if it's another even like a 4th or a 6th root. Okay, that's your general solution. Okay, look at the ordered pair that you were given to find your particular solution. Okay, what is it? What point does it have to pass through? Okay, so my 1 needs to be a x, my -2 needs to be my y. So I'll do -2 equals cubic root. 18, my x is a 1 squared plus c. And then remember, my goal is just to find out what that c has to be. Okay, under the cubic root, what is 1 squared? Follow PEMDAS. Exponent first. 1 squared is 1, and then times it by 18, it would stay 18 plus c. How do we get rid of that cubic root to get c? Cube. And remember, when you cube, you have to do it on both sides. My cube and my cubic root will cross out, leaving me just with the 18 plus c from the middle. And then -2 cubed would be times itself 3 times. So -2 times -2 would be 4 times another -2, -8. Okay, then to solve minus that 18 across, what's your c going to be? -26. Very good. Okay, and then some of us on our test lost points that we never went back and plugged that in. So remember, your particular solution should be cubic root 18x squared and then minus 26. Good? All right, go ahead and turn the page when you're ready. All right, next one, you should be able to separate that. So go ahead and give it a try. So you have your dy dx. It's -9x squared over 2y. So separate, integrate, and then get your y by itself. If you want to check your separation step, it should look like that. So the 2y dy, and then the negative 9x squared dx. And then do integral, don't forget, plus means only on the x side. So 2y, what would your antiderivative be? Okay, good. On the other side, negative 9x squared, what's the antiderivative? Plus C, and then to solve it, we'd have to y equals plus or minus the square root. Negative 9 3x cubed plus C. Okay, from there, you're going to use this information, okay, to find what your plus C needs to be, so that instead of a general solution, you'll have the particular solution. I'll give you a sec to try that. My y values in -3 equal to plus or minus. My x is a 1. Okay, in the parentheses, 1 cubed is going to stay a 1, but then times it by that -3, and it's going to stay a -3 plus C. On the outside, what am I choosing, the plus or the minus, to match my y value? Okay, if I have a minus over here, I need a minus over here. Okay, then to get rid of this square root, I'm going to do what? Okay, square both sides. -3 squared means -3 times -3, which is +9. And then on this side, it's a negative root times another negative root. The negatives cross out and the square root crosses out. So you're just going to keep the -3 plus C. So when I say the negative crosses out, I'm talking about the one on the outside. Okay. Then from there, add the 3 across. What's your C? 12 is correct. Okay, so then your particular solution should be y equals -3x cubed plus 12. Is that right? Okay, it's not right. What's wrong with it? You gotta put the negative. Okay, remember that a general solution, you can leave it as a plus or minus because you don't have a particular point you're trying to match it with. Okay, but by the particular solution, you should have chosen. Okay, now a little bit of algebra 2 here. Okay, if you were asked in algebra 2 to find the domain of this, okay, and actually this is not totally correct. Make sure your 12 makes it inside your square root here. Okay, if you were in algebra 2, you should have done a whole unit on how to find the domain of different equations. So just to simplify, domain just means what can your x be, what can it not be. So if your x is inside a square root, what's the only type of root you can't square root? What's the only type of number you can't square root? A negative. Can you square root a positive? Yeah, even if it comes out to a decimal, you still can square root it. Okay, what about 0? Can I square root 0? What's the square root of 0? 0. So the only thing it can't be is it can't be negative. So your domain needs to allow for this to never be negative. And so if I want it to never be negative, then my domain would be that middle crap has to be greater than or equal to 0. Okay, for me to ensure that I'm not going to end up having to take the square root of a negative, because that comes out imaginary, okay, which would be outside of its domain. Okay, now 9 times out of 10, Okay, for the AP test, this would be good enough. But every now and then, they'll solve this, and so this is an algebra 2 thing. Okay, but let's go back and review how to do that. What do you think you would do first? Go back to what, freshman year? Okay, what do you think you probably would have had to do first? Minus the 12 is correct. So minus 12, which means that now I have negative 3x cubed greater than or equal to minus 12. What would your next step be? Good. Okay, you divide by negative 3, but then there's a special thing that happens with inequalities that anytime you times or divide by a negative, you have to flip your greater than around to be a less than. Do you remember that? So now it'd be x cubed less than or equal to, and then negative 12 divided by negative 3 is and then from there, take the cubic root. Now, 4, I can't easily cubic root that, so I would just leave it like this, that my domain is going to be x has to be less than or equal to the cubic root of. Okay, but really, okay, both of these are correct for domain, but if it's multiple choice, you'd have to know how to get from here to here. Does that make sense? Okay. We're gonna skip number 4, but before we do, it's a y squared, yeah? So when you take the antiderivative, what your y would end up being what power? Cubed, and then at the end you take a cubic root. So I want you to just kind of skip blah blah blah. You would get y equals a cubic root. Okay, so we're not going to actually do it, but I want you to think about the domain. For a square root, I can't square root negatives, but I can do anything that's positive or 0. For a cubic root, would my domain have that same restriction? Can I cubic root positives? Can I cubic root negatives? Can I cubic root 0? Then this would be all real numbers. Okay, so for cubic or odd roots, you don't have any restrictions. You can cubic root whatever you want. Positives, negatives, 0, doesn't matter. Okay, so only for square roots would you really have to worry about them most likely asking you about the domain. All right, so let's go to the next one. Okay, I have x stuff and I have y stuff. What is the operation between them? Divide or division, which means that they are separable. And to separate, if they're divided, I'm going to multiply. So go ahead and do that step first. So my 4y minus cosine y would multiply to the other side. And then my 3x squared would just kind of stay where it's at, but I would multiply the dx over with it. Okay, and then I'm going to group this in parentheses because I had to multiply that whole term across to here. Okay, then integral. Okay, 3y minus cosine y. What's the antiderivative there? Go one term at a time. 4y first. 2y squared. Okay, and then for your negative cosine, think snow cone, snow cone. You're at the bottom of the ladder, you're going to go up 1. What would that put you at? Okay, negative sine y. And then on the other side, I have a 3x squared. What would that go to? X cubed plus c. Now, in this case, there is no way for you to get y by itself. This is still considered a general solution. Okay, and the reason why is there's no way for you to square root and get this y alone because you'll still have another y in the sign. Okay, so there's no way in this case for you to solve it for y, but then this would still count. Now, let me show you when you have to do it. Okay, look at the way this says, find the solution. Look what number 3 says. Finds the solution, and then what does it say right behind that? Finds the solution, y equals. Okay, so if it says y equals, your equation has to also look like a y equals. But if it doesn't say that, you can leave this as is, and this is good enough. Okay? So if it says y equals, get to that spot, but if it doesn't, you're good to here. Now, even though this is kind of an y equals general solution, okay, you can still solve for the c. My ordered pair is 2, 0. So now I'm going to use that to find the c. So my x is going to be a 2, my y is going to be a 0. So my 2y squared is now a 2 times 0 squared. Minus my sine y is now a sine 0. And then on the other side, I have an x cubed would be a 2 cubed plus c. 0 squared is, what about sine 0? Sine 0 is also 0. So this whole side is 0. And then 2 cubed is 2 times 2 times 2 is 8. And so if 8 plus c is 0, then what's my c? Negative 8. Very good. Okay. And then don't forget, just go back to your general solution. Put this number in that spot. And then now it's a particular solution. Okay, so it'd be 2y squared minus sine y x cubed minus 8. But it'll be pretty obvious if you can get y alone or if you can't. Okay. All right, turn the page. Okay, we're going to do 6 and 7, and then we'll be done with notes for today. So take a look at number 6. Your dy dx has 5y minus 2xy. What's the operation, though, between this x and this y? Minus, and that's not one of the separable operations. If you peek back on the first page, what did we say? It has to be times or divide. Minus is not an option. So look at that algebraic expression again. How could I separate the y from the x with multiplication in between? How could we like pull the y out where now it's a multiply y? Greatest common factor, very good. So see how they both have a y? So you would just rewrite it like this. You're going to still have a dy dx, but then you're going to pull the y out so that the 5 minus 2x, now it's multiplied by y, and now that that's a multiplication operation, I can separate it. Okay, now in this case, the y is already on the top. That means the y is multiplied with x. How do I undo that? Instead of multiplying it across, now I'm going to have to do what? Divide the y across. So when I divide by y to cross it out, I'm going to have to do a 1 over y on this side. And then my dx, I'm going to multiply it across so that it'll look like this. I have a 1 over y dy. And then I have a 5 minus 2x dx. Okay, from there, integral. And the left side is a special. Do we remember what the integral of 1 over y would be? Same as 1 over x. What's the integral of 1 over x? It's kind of e-ish. Natural log ln. Very good. Now, if 1 over x goes to ln x, 1 over y will go to ln y. Yeah? So you'll have natural log y equals. Now let's do the antiderivative on the 5 minus 2x side. What will 5 go back to? 5x. And what about negative 2x? Negative x squared plus c. And now I can get this y by itself. If it's in a natural log, how do I cross out the ln? What do I put on both sides? E. Very good. Okay, so I'll put a base e on both sides. My e and my ln will cross out with each other. And I'll have y equals e to the 5x minus x squared plus. That is my general solution. Okay, then they give me an ordered pair right here. That's going to be enough for me to find what my C is. So they tell me f of 1 should be e to the 5th. Then when I plug in 1 where my x is, the answer should be an E5. So I know that I'm going to use this right here, that E5 is the answer when I plug in a 1. And then from there, work out that little exponent. Okay, 5 times 1, that would stay a 5. Minus 1 squared would stay a 1. So what's 5 minus 1? 4 plus C. And then how can I get rid of the base e's? We know we can cross them out, but what are we doing to cancel out the e? Natural log. So I'll ln both sides. That'll cross out my e's. I'll have 5 equals 4 plus c. And then minus that 4 across, what's my c going to be? Okay, that would be okay, then don't forget to finish it out. You should rewrite your equation with the 1 in that C spot. So it'd be y equals e to the 5x minus x squared plus 1. And that's your particular solution. Okay. All right, then I just realized I totally forgot to do part A. So what you did just now was the solving the differential. So let's go back and look at part A. I did the exact same thing first. Okay, part A asks you to do a linear approximation. Okay, we covered this in November. Okay, but does anyone remember what you do for a linear approximation? You write the equation of a certain line, tangent line, and then what do you do with this number, the decimal? You remember you just plug it in as the x. Very good. So I'm going to write here, linear approximation means that you're going to write the equation of the tangent line. And then eventually you're going to take that 3.2 and plug it in. And then plug it into the tangent line. So what are my 2 ingredients? The AP test is 3 months away. Okay, far away, but we want to try to remember stuff. What do you need for a tangent line? 2 ingredients. A point and a slope. Very good. My point is right here.
Please pardon the interruption. I need all RHS steppers to misplace office. All RHS steppers to misplace office. Thank you.
Okay, so my point is going to be 3, -2. And then for my slope, do you remember this guy? You would do dy dx, vertical line, 3, -2. You remember that? Okay, so slope means you're going to take the point that you just got and you're going to plug it into your dy dx equation, which you can see it's right here. So 5y minus 2xy, 5y would be a -2, minus 2xy would be a 2, 3, -2. That's a -10 for the 5 times -2. And then this would be 2 times 3 is 6, times 2 is 12, plus or minus on that though? Plus. So -10 plus 12 means my slope is 2. And then remember, once you have the point and the slope, you're going to put it in point slope form. Okay, so it'd be y blank equals blank x blank. And then remember, the x and the y should go in opposite signs. The slope should go in the same sign though. So my slope is a 2. My y value is a 3, -2. So what will I put here? Good, and my 3 was a positive, so it's going to go in as a negative. And then what are we putting in this x spot that we're trying to estimate? 3.2. So what's 3.2 take away 3? 0.2. So I have 2 times 0.2, which is how many? Close. Double 0.2 would be 0.4. And then you're gonna minus the 2 across. So 0.4 take away 2 would be negative 1.6. Okay. So a little bit of kind of old stuff, but hopefully you remember a little bit. Okay, we have one more left. We're almost done. Okay, try to separate this. Okay, last one for today. You have a DHDT. So the first thing we should notice is that instead of Y's and X's, now we have H's and T's. Okay, but you're going to do it the same way. So H is going to be my Y. T is going to be my X. So my root H is currently on the top. Are my H's and T steps multiplied together? Or divided? Yes, then it's already separable. So how do I separate to get rid of that? Divide it. Very good. So I have dH dt equals 4 root H T minus 2. I'm going to divide a root H onto both sides. And then I'm going to multiply the dt on both sides. Now, you might notice I'm not going to bring the 4. Okay, 4 could go either way. It's just a regular number. So think about, do you like a regular 4 or do you want to have a 1/4 on this side that you have to mess with? So for me, leaving the 4 on this side is better because then it's not going to be a fraction. Okay, you could bring the 4 over, but you're just going to have to get rid of it later anyways. So you really only want to bring across the stuff that you have to. So what I have now is 1 over root H dH. And then 4t minus 2. And then integral. Okay, both of these sides are going to require a rewrite. My H is on the bottom, but it's not 1 over H that it'll go to an ln. Remember, 1 over X is special. Okay, but if your X is in a square root, that's not an ln anymore, that's a rewrite. What power does H have on it if it's in a square root and it's on the bottom? Negative 1/2. Very good. Okay, so my rewrite for that is that this is really the antiderivative of H to the minus 1/2. Okay, and so if you think about that, that should make sense, that the half comes from the square root, the negative comes from the fact that it's on the bottom. Okay, on this side, there's no product rule, but this is an easy fix. What can I do with the 4 to get rid of the parentheses? Yeah, just distribute it. So if I rewrite on this side, now that's a 4t, and then 4 times minus 2 is a minus 8. And then we're ready to do the antiderivatives. Okay, let's start with the t side just because it's easier. T is going to go up to what power? T squared. And then I'm going to divide the squared on the 4 that was already in the front. That's going to turn it into a what? 2. My minus 8 is going to go back to a what? Minus 8x, or in this case, it's a t. Don't forget plus c. Okay, from there, my h side, I have a negative 1/2 as a power, and I need to add 1 to that. What is negative 1/2 if I plus 1? Positive 1/2. Then I have to divide by positive 1/2, which is the same as if I flip it to the front, what number would I put there? 1/2 flipped is 2. Very good. Now we want to get this h alone, and we have a times 2 in the front. How can we undo that? Divide by 2. And when I divide by 2, I'm going to do it all the way across. Okay, except on my c. Because remember, I already didn't know what c was, so I don't care about making it half of c. If it's unknown, it's unknown. You can just leave it. So now we have the square root of 8. 2 divided by 2 is now a 1t squared. 8 divided by 2 is a 4t. And then my c is chilling. I already didn't know what it was anyway, so we're going to leave it. Okay, last step, I need to get rid of that square root. What am I gonna do? Square, and when you square, make sure you group these guys together. Okay, and square them as a like whole unit. Okay, that is your general solution. Okay, so I'm just gonna put GS for that is H equals 1t squared minus 4t plus c squared. Okay, then from there, my ordered pair is 1, 1. That would be enough information for you to go back and find your C. Okay, so go ahead and give it a shot. 1, 1, you're putting a 1 in for the H. You're putting a 1 in for the T. So it'd be 1 times 1 squared minus 4 times 1 plus C quantity squared. 1 squared is 1. Times it by 1 is still a 1. What's the middle number gonna stay? -4. What is 1 minus 4? -3 plus C. What do I do next to get rid of the squared? We're trying to get to that C. Square root of 1 is 1. Squared and square root cross out, giving me a -3 plus C. Last step, what do I do with the -3? So my C would be. Okay, and then remember, it is acceptable on the AP test. If you want to go back to this, cross out the C and put in a 4. Okay, that is fine. You just need to have it written all together somewhere. So now this would be your particular solution. Okay? You get it? Kind of? Okay. If you are all caught up and you're going to do the homework on this, no level 2s. Okay, we only covered level 1s. So you can do the first part of the homework, but remember the order. Most important, College Board assignment. You can ask each other for help as much as you want. You can't ask me. Okay, and then homework, old homework first, and then this homework should be last because you have the longest to do this. Okay? You have 45 minutes. If you want to move desks, you're welcome to do that. To sit by a buddy or something, that's fine. I do. There's one right over behind that little chair that you can use.